In this video, I'm going to review several things about the equations and graphs of ellipses. The first thing I will do is show you how to graph an ellipse given the equation, and then I will show you how to come up with the equation when you're given different information like the co vertices or the major axis. And finally, I will show you how to create a standard form equation that can easily be graphed when you're given a general form equation like this. All right, the easiest thing to do with number one is to start with the center. In this form, you can just look for the opposite of this, comma, the opposite of this. So the center is going to be -3, comma, +4. So that means the center is going to be right here at -3, 4. All right, next let's find the vertices. Look for the bigger denominator to lead you to the vertices. We go ahead and call this bigger number a squared, which allows us to say that the a value is 5. Now this tells us two things. This is going to be the distance from the center to the vertices, but the fact that it's underneath the x squared term tells us that the a value, this 5, will be in the horizontal direction. So I'm going to be going left and right with my 5. And that's left and right from the center, all right, from this point -3, 4. So because my a value is 5, I'm going to go left 5, and that's going to be a vertex, and I'm going to go to the right 5, and that's going to be a vertex. So this is the point -8, 4, and this is the point 2, 4. So those are my vertices. All right, now let's find the co-vertices. We can find the co-vertices by looking at the smaller denominator, which we will call b squared, which means that b is equal to 3. Now that b value is the distance from the center to my co-vertices. And the fact that the b value came from this 9, which is with the y squared term, you know that y is a vertical thing. So we will do this plus and minus 3 vertically from the center. So I'm going to go up 3 and down 3. So these are my co-vertices here at -3, 7 and -3, 1. And now we can draw the ellipse. All right, and the only thing we need now are the foci. The foci can be located once we find the c value. And we know that the relationship between a, b, and c is c squared is equal to a squared minus b squared. So c squared is going to equal the 25 minus the 9. So c squared is 16. So that means that c is equal to 4. Okay. So that we know that the foci will be on the major axis, meaning on the same line with the vertices. But that c value of 4 tells me to go 4 away from the center. So I'm going to go 4 to the right from the center, and I will go 4 to the left. Okay, so my foci are -7, 4 and 1, 4. All right, again, the foci are always sitting on the major axis. They are always on the same line with the vertices. All right, they're always the long way. All right, problem number 2 is a little bit different. We are given the co-vertices and the length of the major axis. That means the long way from vertex to vertex will be 20. So let's graph these, and that will make it easier. So the co-vertices are at 5, -5. All right, so there will be a co-vertex right here. And there's another co-vertex at 5, 3. All right, these are my co-vertices. This also tells me what the center is going to be, because the center will be halfway, it will be the midpoint of this segment. So I can see that the midpoint is right here. So that means that the center of this ellipse is going to be 5, -1. So this tells me a great deal of information. So first of all, the fact that the center is 5, -1, and you know what, let's go ahead and write that down. That's going to give me half of my equation, because the numerator, because of the 5, I'm going to have x minus 5, all right, it's always the opposite sign, squared. Okay, and because of the -1, I will have y plus 1 squared. And for ellipses, it's always equal to 1. So all I need now to finish the equation are the denominators. But it gets even better than that, because we are also given the b value. All right, we are told we're given the co-vertices. So that means if you look at this distance right here, all right, this is going to be the b value. And this distance is 4. So my b value is 4. That tells me that b squared is 16. So that's my denominator. And I can see that this is vertical. So this 16 should go underneath the y squared term. All right, so that tells me I'm going to put 16 right here. Now, all I need to do is find my a squared value to put right here. Now I'm going to use the fact that the major axis is 20. So because the major axis is 20, all right, it's got to pass through the center, of course. But a total of 20 means 10 in each direction. So if I go 10 to the left, that's going to put me right here. So that should be a vertex. And if I go 10 to the right, and I'm going to have to estimate a little bit, because it's obviously going off the graph here. But if I go 10 to the right, that's going to be about here. Okay, so this vertex is the point -5, -1. What about this one that's off the graph? Well, I started at 5, and I'm going 10 to the right. So this should be 15. Okay, so this vertex is going to be 15, comma, -1. And so now I'm going to draw, well, you know, I should list those. So the vertices are -5, comma, -1. And 15, comma, -1. Oh, you know what? There was a spot for the equation right there. I'm going to go ahead and draw the ellipse and see how close I came with this point off to the side. I might have missed badly, but I guess we'll find out. You know what? I guess I could make it fit. Okay, so there is my graph. Also, because the major axis was 20, this is my A value right here. Okay, my A value is 10, half the major axis, which means that A squared is 100. So that's going to be my other denominator. Notice that this is horizontal. It's in the x direction. So it makes sense that this 100 should be in the denominator of the x squared term. All right, there's one more thing we need to do, and that is find the foci. So the foci are associated with what we call the C value. So far, we have discovered that the A value is 10. Okay, that's how we got the 100. The B value was 4. All right, that's where the 16 came from, B squared. And now we need to find the C value. So remember, of course, that C squared is equal to A squared minus B squared. So C squared is equal to 100 minus 16. So C squared is going to equal 84. So C is going to equal the square root of 84. And we need to simplify this. Well, 84 is 4 times 21. So that means that C is going to equal 2 radical 21. All right, this is what we're going to use as we build the foci, the expression for the foci. But for graphing purposes, it will be useful to have the decimal approximation for this, which is about 9.2. Okay, so as far as locating these on the graph, we know that the foci will always be in line with the vertices. And so they're going to be the long way. So if I go 9.2 in both directions, that should give me the foci. So if I go 9.2 to the left, that's going to be about right here. If I go 9.2 to the right, that's going to be about right here. Okay, now, how to label these though? What to call them? Because remember, we're not starting from the origin. We started from an x value of 5. We know that the y value is going to be -1, all right, just like the vertices, just like the center. All we have to worry about is the x value. And here's what you do. Look at the center. We started from 5, and then we went to the left. Okay, as far as decimals go, we went to the left 9.2. But in perfect radical form, we went to the left 2 radical 21. So that means that we started at 5, and we subtracted 2 radical 21. So this is an expression for the x value. The y value is -1. Similarly, for the focus that's on the right-hand side, we started at 5 and we went to the right 2 radical 21. So that means we started at 5 and we added 2 radical 21. This is an expression for the x value of this focus. And again, the y value is -1, just like all of the other points that are at this height. So let's just record that. So the foci are 5 minus 2 radical 21, comma -1, and 5 plus 2 radical 21, comma -1. All right, this is pretty much the trickiest thing that students have trouble with. All right, in this last problem, we are given the equation of an ellipse that is in general form, and we need to rewrite it in standard form so that we can go ahead and graph the ellipse. So that's going to take a little bit of space, so I'm set up for it down here. All right, basically we're going to be completing the square. To do this, we need to group together the x terms and the y terms. Okay, and I'm going to take that 100 and move it to the other side by subtracting it. So grouping these x terms together, you'll see that I have 4x squared minus 40x, and then I have plus 9y squared plus 36y. Okay, and that's going to equal -100. All right, so I grouped my x terms together and my y terms together, and I moved the extra constant out of the way. So now, because I have this leading coefficient of 4 for the x terms, I need to factor that outside of parentheses. So this is going to become 4 times x squared minus 10x. Now, I need to leave a little space here in order to complete the square. Okay, similarly, I have this 9 here in the front. I need to factor that outside of parentheses as well. So that's going to become 9, and then y squared plus 4y. And again, leave a little space here to complete the square, equals -100. So now it's time to complete the square. So the way we complete the square is we do half of the middle squared. So half of this is -5. But if we square that, we're going to get positive 25. Now, we need to add something to the right-hand side of the equation to balance this out. But guess what? It won't be 25 because this is not really 25. It's really 4 times 25. That is 100. So I need to actually add 100 to the right-hand side to balance this out. Similarly, with the y part of the equation, I'm going to complete the square again. Half of the middle is 2. You square that and you get 4. So again, I'm doing half the middle squared. But again, I will not add 4 to the right-hand side to balance it out. It's really 9 times 4. So I'm going to add 36 to the other side of the equation in order to balance this out. So as I rewrite things, I've got this 4. This is going to always factor as the same thing twice. So this is going to factor as x minus 5 times x minus 5. And this is going to factor as y plus 2 times y plus 2. Now, of course, these 100s cancel each other out, and I just have 36. Okay, so now I can write x minus 5 squared plus 9 times y plus 2 squared is equal to 36. In standard form, for an ellipse, we always have a 1. We always want the equation to equal 1. So that lets us know that we need to divide everything by 36, because that's the only way we're going to get a 1 right here. So I needed to divide both sides of the equation by 36, and on the left side of the equation, that will look like this. Now we're basically reducing these fractions. 4 over 36 would reduce down to 1/9. So that's why I'm going to have x minus 5 squared over 9. Similarly, a 9 over 36 would reduce down to 1/4. So that's why I'm going to have y plus 2 squared over 4 is equal to 1. So this is the equation that we were looking for. Now that we have the standard form equation, we can gather the rest of the information we need and do the graph as usual. So let's start with the center. Looking at these parentheses, I'm just going to do the opposite of each of these numbers. So my center is going to be 5, comma, negative 2. Let's go ahead and plot that. Okay, so 5, comma, negative 2. So my center is right here. Okay, so everything else I do will be based off of this. I will go left and right from here, and I will go up and down from here. All right, so let's talk about the vertices. For the vertices, I need to look at the larger denominator. Let's call this large denominator a squared, which means that a is equal to 3. We will use this 3 to get the vertices. Notice that a squared is in the denominator of the x squared term. The x direction, that's horizontal. So when I do my plus and minus 3, I'm going to do it horizontally. Okay, so starting at the center, I'm going to go 3 to the right, and I'm going to go 3 to the left. These are my vertices. So you see, I'm at 2, comma, negative 2, and 8, comma, negative 2. Those are the vertices. Now, what about the co-vertices? Well, the co-vertices are going to come from the smaller denominator. Let's call it b squared. So b squared is equal to 4. That means b is equal to 2. Notice that b squared is the denominator of the y squared term. Y, that's the vertical direction. So when I do this plus and minus 2, I'm going to do it vertically. So I'm going to go up 2 and down 2. These are my co-vertices, which are 5, comma, 0 and 5, comma, negative 4. Let's write that down. Okay, so I really could draw the ellipse right now, even though I still have to get my foci going. I'll do that in a moment. Okay, that's pretty neat. Now, how about those foci? Now, keep in mind that the foci will always be on the major axis. They will be going the long way, just like the vertices. So my foci will be horizontal. So, to find the foci, I need the c value. All right, we've got our a value, we've got our b value, we need the c value for the foci. We know that for an ellipse, c squared is equal to a squared minus b squared, which means that c squared is equal to 9 minus 4, which means that c squared is equal to 5, which means c is equal to radical 5. Now radical 5 is approximately 2.2, and I will use that to help me graph, but when I label things, I will use the perfect radical, all right, as opposed to an approximation. So, using the 2.2, imagine going 2.2 to the right of the center and 2.2 to the left of the center. Okay, so I should have a focus here, and I should have a focus here. Now, what are the coordinates of those points? And I'm not going to use 2.2 now. I'm going to use radical 5. So, look what I did. I started at the center, and I went left 2.2, and I went right 2.2. But that 2.2 is really radical 5. So when I say that I go left radical 5, that means I'm subtracting radical 5. I'm starting at 5, and I'm subtracting radical 5. So the x value of this point is going to be 5 minus radical 5, because I started at an x value of 5 and I went to the left by radical 5. The y value is the same as all of the other y values on this line. Okay, this point is down 2, so the y value is negative 2. So those are the coordinates of that focus. Okay, 5 minus radical 5, comma, negative 2. All right, similarly, the other focus, all right, the tricky part is the x-coordinate. And again, we started at an x-coordinate of 5 at the center, and we went to the right. But instead of saying that I'm adding 2.2, I'm going to say that I'm adding radical 5. So I started at 5, and I added radical 5, all right, by going to the right radical 5. And again, the y value is still negative 2, because this point is also down 2, just like the center, just like the vertices. So my second focus is at 5 plus radical 5, comma, negative 2.